All right, welcome back. So now let's go and get into the processes for this section of simplifying rational expressions. So again, like the other process videos I do have kind of like some steps for you to follow, as well as some tips that are generally like good to use, if you're getting stuck or you just kind of forget like which steps you should follow, when you should do them, and what you should look for. So again, I definitely recommend, looking at them and kind of following the process, but it's not you have to do this step and then you have to do that step. It's really just there as a guide to help you along. But I'm going to go ahead and work through these step by step and just practice simplifying our rational expressions as well as identifying the excluded values that we talked about in the notes. So typically when you're simplifying a rational expression, we want to apply the division property. That means we need to create our expressions separated by multiplication. So typically we're going to be looking to rewrite our expressions in the numerator and the denominator as a product. So in this top equation, in the top of this expression here, I'm looking to factor out a 3. So I factor out a 3, that's going to leave me with a x squared minus 4. And then the denominator here looks like I can factor out a 3x squared, and that's going to leave me with a x minus 2. All right. Now here you can see the 3's get divided out, but let's just try to get this completely factored out before I go ahead and simplify. I notice up top here, I can simplify that to x minus 2, x plus 2. That's a difference of 2 squares. And then I can't really do anything else in this denominator. So I'm just going to leave that there. All right. But hopefully you recognize that the x minus 2's divide out and the 3's divide out. Now that will give us a simplified expression of x plus 2 divided by x squared, right? Now again, we have to be careful of one, we can't apply the division property anymore, right? Because you can see the x and the 2 are separated by addition, not multiplication. So we can't apply the division property. In terms of the excluded values, we have an excluded value here where, so I'll write, where x cannot equal 0. We know that x cannot equal 2, even though it got divided out in the original expression, 2 would make this quantity 0, which would make the whole denominator 0. However, I'm not going to include 3 because even though 3 got divided out, it's not an excluded value. 3 does not make the denominator equal to 0. Yes, it gets divided out. It's a scalar, but it's not an excluded value. So just be careful with that. A lot of students, they factor out the x minus 2 and then they divide out the x minus 2, then they divide out the 3, and they want to include both of them as excluded values. Remember, excluded values are only going to be the values that make the denominator equal to 0. So in this next example, you can see that we have a trinomial in the numerator as well as a trinomial in the denominator. So what we're going to do is just factor the numerator as well as factor the denominator. So up top here, we know that all trinomials can be written down or factored down into a product of two binomials. And that's true in the numerator as well as in the denominator. Okay. Now in the denominator, it's kind of rather simple. We're looking for what two numbers multiply to give you 6, add to give you 5, and that's just going to be a plus 3 and a plus 2. And again, you can multiply that out to make sure that checking my work. On the numerator here, we're looking for two numbers that multiply to give you 3. So that'd be like 3 and 1, right? But we want them to add to give us 7. So therefore, I want the 3 to be here and the 1 to be here. Whereas here, the order doesn't matter. But here, the order does matter because the 2x I needed to multiply to 3 to give me 6x, and then add this 1x will give me 7x. Hopefully from here, you can see that the x plus 3's are going to divide out, leave me with an expression of 2x plus 1 divided by x plus 2. Again, we cannot divide out the 2's because we have our terms separated by addition, but we can write our excluded values where x cannot equal negative 2 and x cannot equal negative 3. Again, even though it got divided out, it would still make the denominator 0 from the original expression. In this next example, typically when we're simplifying, I always like to have things written in standard form. So I'm just going to rearrange this as well as factor out the x. So by doing that, I get a factor out x squared, I get minus 1. All over a negative, and then when I factor out the negative, that gives me a positive x squared plus x minus 2. All right. Now the negatives, just like the 3's, are just going to divide out. And then I can further factor down the x squared minus 1. So that would give me a x minus 1 times a x plus 1. And the denominator here, I could say what two numbers multiply to give me negative 2, add to give me a positive 1. That's going to be x plus 2 times a x minus 1. So therefore, you can see those terms divide out, leave me with a x plus 1 over x plus 2, where x cannot equal negative 2 and positive 1. In the next example, again, you can see that now we're just doing some polynomials that are a little bit higher order, so that's perfectly fine. Remember, whenever we have a trinomial, we want to look into factoring it like a quadratic trinomial. So I can think about this as a, x squared minus 5x plus 6. And if I wanted to do it that way, I would say, what two numbers multiply to give me 6 but add to give me negative 5? And I can think of that would be x minus 6. Now let's redo that. That'd be x minus 6, x plus 1. Okay, however, I'm not trying to get this multiplies to give me that. I'm trying to get it so it equals this. So instead of x times x give me x squared, I want x times x to give me x to the fourth. So I'm just going to raise the powers there. Over here, this is going to be something I'm going to want to factor by grouping. So what I'm going to do is I'm going to rearrange this to x squared plus a negative 2x minus 4. Right, so I'm just changing the subtraction problem to an addition problem. Group the first two terms, group the last two terms, factor out the GCF for each term. So that's going to be with an x plus 2. And then here I can factor out a negative 2. And that's going to leave me with a x plus 2. Now I can factor out the x plus 2. And that's going to leave me with a x squared minus 2. And that does not work because that gives me a negative 6. So I actually factor that incorrectly. I'm an idiot. I'm not an idiot, but I want you to kind of actually go through. This is a good mistake to make because I was like, I don't remember this answer not having something to simplify. So you could think about, oh, well, this doesn't multiply out, right? But I made the classic mistake with the 6's, and this is what everybody, it's very common to do. Negative 6, yes, negative 6 and 1 add to give you negative 5. But again, check your work. Negative 6 times positive 1 does not add to give you a positive 6. So those factors are incorrect. And I already did this problem, so I can't believe I even made that mistake. But the answers here are negative 3 and negative 2. Negative 3 times negative 2 gives me a positive 6. Negative 3 plus negative 2 gives me a negative 5. Now you can see that those divide out, leaving me with my final answer of x squared minus 3 divided by x plus 2. Now, to figure out my my undefined values, I know x cannot equal negative 2. But in this case, what makes this 0? So again, just set it equal to 0. Right? Sometimes we'll have easy numbers. Sometimes we won't. So set this equal to 0, and you get x squared equals 2, square root, x equals plus or minus the square root of 2. Okay, so that's the simplifying the expressions, basically always looking into factoring and applying the division property. Now let's get into adding and subtracting rational expressions. And again, this is really going to be the same. A lot of things like what we want to do first is always simplify them and then identify the common denominator. So if it's not easily identify what the common denominator is, one of the just quick tips to do is just multiply your two denominators. So in this case, I can see that the common denominator, I don't know what x times x plus 1 have in common. So I'm just going to write the product. I'm just going to write the LCD is going to be x times x plus 1. Now there's nothing really I can factor out here. So all you're simply going to do is multiply. Oops, I'm sorry. You're going to multiply each expression by whatever scalar or factor you need to obtain the x times x plus 1. So on this right-hand side, I already have x plus 1. So if I need to get x times x plus 1, I'm going to multiply by an x. Now just make sure you do that on the top and the bottom because that's going to produce an equivalent fraction. On this left-hand side, I only have an x in the denominator. So therefore, I need to multiply by an x plus 1 on the top and on the bottom. All right. Now before we go and get to the work, hopefully you already recognize that my two values, my two excluded values is x cannot equal 0 and x cannot equal negative 1. All right. So those are typically we would just want to get those out of the way so we remember to write them in on our final answer. So here on the left-hand side, hopefully you recognize that's a difference of two squares. So we have x squared minus 1 all over x times x plus 1. And then over here, we're going to have a minus. Let's see, that would be, just use parentheses, distribute this. So there'd be a x squared plus 2x. All right, so I'm distributing. Make sure you distribute that to both terms. But again, remember that's outside of a subtraction or your difference here, and that's going to be x times x plus 1. Now I have my two fractions that have the same denominator. So I'm just going to apply the distributive property to subtract, and then you're only going to subtract the numerators to keep the denominator same. So therefore I have a x squared minus x squared. Let's see, minus 2x minus 1 all over x times x plus 1. And therefore that gives me a final answer of a negative 2x minus 1 all over x times x plus 1. And We can just simplify that. We can leave that together. You can distribute that if you want to. It really just kind of depends on the directions and what your teacher is looking for. And there you go. And then just make sure you add your excluded values at the end. Now for the next one, you can immediately look at this and say, oh, well, let's multiply the two LCDs here. But that doesn't seem like very much fun. And that seems like a lot of work. So, we always want to look into simplifying if we can. And when I simplify this, I recognize that this can be rewritten as x plus 1 times x minus 3. Well, that's important because now you can see that these two denominators share the x plus 1. So I actually, to obtain the common denominator, I'm just going to say the least common denominator is just going to be x plus 1 times x minus 3. So then all I need to do is multiply an x minus 3 on the right-hand side over here. So then I'll have a 2x squared minus 3. Oh, sorry. Let's go ahead and get our excluded values. X cannot equal -1 and +3, right? Because those are the two values that make my denominator equal to 0. So I have 2x squared minus 3 all over x plus 1 times x minus 3. I like using the factored form. Plus, again, we can use the distributive property here, x squared minus 3x divided by x plus 1 times x minus 3. All right, and now we can just combine our like terms in our numerator and then keep the denominator the same. So that will obtain a 3x squared minus 3x minus 3 all over x plus 1 times x minus 3, where x cannot equal 1 and 3. Okay, so just keeping those excluded values. All right, so now let's get into the multiplying and dividing rational expressions. So remember, for adding and subtracting, to apply those operations, we had to have a common denominator. For multiplying and dividing, we don't. For multiplying, you just multiply numerator times numerator, denominator times denominator. For dividing, it's a lot easier just to think about multiplying by the reciprocal. And I think it's really important when you are doing multiplying and dividing to simplify, simplify, simplify. Because again, when you're multiplying, if you already have terms separated by multiplication and then you're just adding another multiplication, you can easily just go ahead and apply the division property. So that's why I'm using this x here. I'm just going to kind of show you. When you multiply, everything is really just getting together, right? Numerator times numerator, denominator times denominator. So I can just write this as one big fraction. All right, so I'm going to factor this, or try to factor as many things as possible. Over here, this can be factored down into a again, don't make the same mistake, right? X minus 3 times x minus 2. And then times, this can be factored, I can factor out a 4. And then outside that 4 here, I would have a x minus 1 times x plus 1, right? Because if you factor out a 4, that gives you a x squared minus 1. Okay, and then this could be a x minus 3 times x minus 2. Okay, here you can factor out a 2. That would leave you with you can factor out a 2x. So if you factor out a 2x, that would leave you with a x plus 1. And then here you could factor this to be a, a x plus 4, and then times an x minus 2. Right? So you can see how everything's separated by multiplication. So now it just comes into the game of what can we divide out? We can divide out the x minus 2s. We can divide out the x plus 2s. We could divide the 2 into the 4 2 times. And then everything else that's left over here is I'm going to be a 2 times x minus 3 times x minus 1 all over a x plus 4. Okay? But then again, we need to go back through our excluded values. So what were all the numbers that made our denominator equal to 0? So we can say x cannot equal, let's see here, 0, -1, -4, and 2. So all these values made the denominator equal to 0. So therefore, we don't want to exclude them. Or we have to exclude them from our, exclude them as defined values. Now for division, again, the easiest thing to do is just to rewrite this as a multiplication problem by multiplying by the reciprocal. And in term of doing that, or in the process of doing that, it's also helpful just to go ahead and factor them. So in this numerator, I can break this up into a product of two binomials. What would I need to multiply here to give me this? I'm looking at, I would say this would be a 2x times x. So 2x, I need to get a positive there. So I'm going to say +1 and then -1. That give me a positive 2x, that give me -1. That gives you -1, that's perfect. Divide by 6x, and then times, now I'm going to just switch these, flip the numerator and the denominator, So this gives me a 3x squared. And then this is now going to give me a, let's see, I can factor out an x here. So I'd have a x times a 2x minus 1. Okay. Now, it's also important to understand our restrictions here. So in this denominator, I know x cannot equal 0. And here, x cannot equal 0, so I don't need to write it twice. However, now I have a new restriction. Now the x times 2x minus 1 is in the denominator, right? So you can see that, hopefully you see that x cannot equal 1/2. 0 is again repeated, right? But we also have a new restriction where x cannot equal 1/2 because now the numerator, when I rewrite this as multiplication, the numerator is now in the denominator. So now I'm going to have two restrictions. In terms of simplifying this, the 2x minus 1s, those will divide out. The x divides into an x squared. And we'll just say that x times. So therefore, I will be left with a 3x times x plus 1 divided by a 6. Yeah, divided by 6. There you go. But x cannot equal 0 and 1/2. So, oh, did I not simplify those? I did not. They go to 2, right? So, my bad. And then in this case, you guys could actually see, you could actually don't even need to rewrite this like this. You could rewrite it like this, x times x plus 2. So x cannot equal 0 and 1/2. There you go. So you could actually not even write it as a simplified rational expression. All right, and then onto the last one, guys, is the complex fractions. So again, when we're dealing with complex fractions, there's way too many fractions to deal with. So what I'm going to want to do here is multiply by the LCD. So again, when it seems like they have a common denominator, you know, here it's going to be 1 and 1. So in this case, the LCD is going to be just x plus 4 because that x plus 4 and 1 all divide into there. So I'm just going to write the LCD equals x plus 4. All right. Now again, well, I'll get to that in a second. It kind of gets confusing here. So we just multiply everything times x plus 4. Everything. All right. And when I multiply x plus 4 times 3 over x plus 4, that gives me 3 minus 2 times x plus 4. All over here, I would get 5 times x plus 4. And then here, plus 2. All right, and then we can apply a little bit of distributive property. But again, the main important thing I want you to see is we went from having, you know, 3 fractions in the numerator, fractions in the denominator, and then a whole fraction to now just having one fraction. So just go ahead and apply a little distributive property here. So I have 3 minus 2x minus 8 over a 5x plus 20 plus 2. And then combine my like terms here. I have a negative 2x. 3 minus 8 is going to be negative 5. Divided by 5x plus 22. Okay, and now we need to go back through our restrictions. So we say, all right, well, x cannot equal. Well, we see that x cannot equal negative 4, right? Negative 4 makes the denominator equal to 0, so can't have that. So x cannot equal negative 4. What about over here? In the simplified expression, if you set 5x plus 22 equal to 0, you would get x equals negative 22 over 5. So x cannot equal negative 22 over 5, right? That is our new simplified denominator. And then what about this whole denominator up here? What about if you take the whole denominator and I have 5 plus 2 over x plus 4, right? We can't, any values that make this 0 is going to be undefined as well. So when we do this, you'd have 2 over x plus 4 is equal to negative 5. And then you have 2 is equal to negative 5 times x plus 4. So 2 equals, let's see, negative 5x, let's see, minus 20. And then therefore that's going to give you the negative 22 over 5. So that still works. So x equals negative 22 over 5. So there you go. So two different ways you guys can see why negative 2 over 25 is not going to be included in the domain. Now for the next one, we have a lot of denominators. And just simply multiplying all the denominators together doesn't sound like that much fun. So again, I look to factor this x minus 3 times x plus 2. And I say, oh, my x minus 3 and x plus 2 are included in this domain. So therefore, my LCD is just going to be x minus 3 times x plus 2. Because does x minus 3 divide into that? Yes, they would divide out. You'd be left with x plus 2. Does x plus 2 divide into this expression? Yes, it divides into their x minus 3 times. Does the whole thing divide into itself? Of course it does. So again, when you multiply this, and maybe I'll write this one. When you multiply x plus 3 times x plus 2 times the whole expression, I don't have time to do that. Come on. So that's my LCD. So what I'm going to do now is multiply everything times x minus 3 times x plus 2. Okay, so when I multiply this expression times there, the x minus 3 divides out, and that's just going to leave me with a 4 times x plus 2. When I multiply this expression times x plus 2, the x plus 2's divide out, leave me with a negative 2 times x minus 3. And then here, this evenly divides into itself, leave me with the number 8. And then in this case, I can just apply good old distributive property, and I get a 4x plus 8 minus 2x plus 6 divided by 8, and therefore that'd be a 2x plus 14 divided by 8. Now, there's no undefined values here, right? 8 is just 8 in the denominator. But if we go back to my original expression, we know that x cannot equal 3 and x cannot equal negative 2. And if you set your equation, your original, the larger denominator equal to 0, you'd have 8x squared minus x minus 6 equals 0. So therefore 8 would equal 0. There's no other values that are going to make this equation equal to 0. So x cannot equal 0 when you multiply the x. What you do is you'd multiply the x squared minus x minus 6 to both sides, but you see 8 cannot equal 0. So therefore my only defined values in this case, put this a little bit over there, is going to be from the original equation, x cannot equal negative 2 and 3. All right, the next one. Whoa, again, a lot of denominators, right? But again, you can see these are repeating themselves, 2x minus 5, 2x minus 5. So therefore, I can say that the LCD in this case, and actually, you know, let's do it a different way this time. So the LCD in this case is, I would say, is just going to be 2x minus 5 times x minus 5. So rather than putting brackets around everything and showing you these little lines, let's actually just physically multiply everything times 2x minus 5 times x minus 5. So let's write it over here. So I'll do 2x minus 5 times x minus 5. Let's do it over here, 2x minus 5 times x minus 5. And then let's do this one, 2x minus 5 times x minus 5. So when I do the brackets, that's essentially what I'm doing. I'm distributing the LCD to every single term. Sometimes a little bit easier to understand it this way because you can see how things actually get divided out. Here you can see these 2x minus 5s are divided out. Here you can see the x minus 5s are getting divided out. So therefore, in the numerator now, I'm going to be left with a x squared minus 25. Oops, I'm sorry. That's a perfect square trinomial. So that's an x squared minus 10x plus 25. Over here, that's going to be a difference of two squares. So that's going to be x squared minus 25. And then minus over here, make sure, again, you kind of maybe use brackets if you need to. You're basically just multiplying x plus 2 times 2x minus, or 2x minus 5. So that would give you a 2x squared. Let's see, that would be a negative 5x. That would give you a positive 4x. That's going to be a negative x, and then minus 10. Whew, okay. So then I can just go ahead and distribute and then combine like terms. So I'll get a x squared minus 10x plus 25. And then over here, let's see, that's going to leave me with a negative x squared plus x. And then that'd be a plus 10, so that'd be negative 15. Okay, so now let's go and look at our excluded values. So we know we cannot have 5, so x cannot equal 5. We know x cannot equal 5 halves, right? Because if you set 2x minus 5 equal to 0, add 5, divide by 2, you cannot have 5 halves. And then what about this larger denominator? What about like this whole, well, actually, what about this new denominator set equal to 0? So, because actually, if you set these equal to 0, the two equations that are going to make this true are going to be 5 and the 5 halves. So let's go and take a look at, yeah, there'd be 5 times 5 halves. So let's go and take a look at this expression, my new simplified version. So therefore, I take a negative x squared plus x minus 15 equals 0. Well, you can factor out the x, right? That equals 0. And then here, hopefully you recognize that this is going to be, if you did your discriminant, b squared minus 4 times a times c, you'd recognize that's going to be less than 0 because you'd have a negative 1 squared minus 4 times 1 times 15. All right, so since it's less than 0, there's going to be no real solutions. So therefore, there's no other further restrictions in this case. And then let's just go ahead and verify actually up further here. Just make sure that these are not going to the denominator. Is not going to have anything else that would be extraneous. So if I said this needs to be x plus 2 over x minus 5 equals 0. So therefore I can set x plus 5 over 2x minus 5 is equal to x plus 2 divided by x minus 5, right? Just add that to the other side. You can apply little the cross product here to get x squared minus 25 equals, again here, what you would have is going to be a 2x squared, and therefore this would be a minus 5x or 2x minus 5 times x plus 2, right? So that's going to be this 2x squared minus x minus 10. And again, you can see that this is going to be the exact same thing that we did over here. We're going to combine, we're going to get the exact same values that are going to equal here. So when you look at this, setting this denominator equal to 0, right? Because we can't find values that set the denominator equal to 0. You can see that we're going to arrive at the exact same answer. When you go ahead and combine like terms, you can subtract the x squared, you can add the 25, and you get 0 equals, let's see, a x squared minus x plus 15. And again, when you go ahead and solve this, as we already determined from the discriminant, there's going to be no values that make this denominator 0. So our only excluded values, guys, are going to be 5 and 5/2. All right, into the last example. Now here we have a lot of denominators, right? And in this case, I can see that my LCD is going to be 3, because 3 has to be in there. It's only in one denominator. It's not in the rest of them. I have to have an x. And then I also have to have the expression x plus 1, right? Because you can see this is x times x plus 1. So you just can't include the x. Like you say, here's the x, and then here's the x plus 1. But those are different, right? So you have to make sure you include both of those. You just can't include the x. So just for simplicity purposes, I'm just going to multiply by 3x times x plus 1. All right, and when doing that now, the 3x will divide out. I'll be left with 4 times x plus 1 plus 2. The x plus 1s divide out, so that'll be times 3x. In the denominator here, the x plus 1s divide out, so that'll give me a 3x times x, so 3x squared. And then here, the x times the x plus 1s divide out, so that'll give me a negative 12. All right. And then I can just apply some good old distributive property, and this will give me a, let's see, a 4x plus 4 plus a 6x divided by a 3x squared minus 12, which equals, let's see, a 10x plus 4 divided by a 3x squared minus 12. Okay. Now again, let's go back and to look at these two values. So we look at this and we say, all right, we know that x cannot equal 0 and x cannot equal negative 1, right? Because those are two values that make your denominator equal 0. And then again, the simplified product, if you notice, like, do you recognize when we took this denominator, set it equal to 0, it gave us the exact same solution than if we just have our simplified product, right? So when I go ahead, rather than setting this whole denominator equal to 0, I can just go ahead and solve for here. And I know that these values cannot equal 0 as well. So that'd be a 3x squared equals 12, and then divide by 3, and x squared equals 4, square root, x equals plus or minus 2. So not only can x not equal 0 or negative 1, x cannot equal plus or minus 2. And there you go, ladies and gentlemen. That is how you simplify your complex rational fractions. You add and subtract, multiply, divide rational expressions, as well as simplified. I know it was a lot, but I think it's very helpful to be able to have this practice. So therefore, you just get more confident as we move through the next two sections, which are going to be graphing and solving. So I look forward to seeing you on the next video. Cheers.